Hey there guys, I'm back, and in this video I'm going to tell you something about the imagination. You might be thinking that I'm kidding, but the answer is no, I am not kidding. I'm going to tell you about the imaginary unit. Did I mess with the spelling? Yes, I think I did. Yes. Something about the imaginary unit in mathematics, and that is iota. Now, by definition, I squared, just a second, I squared is equal to minus 1. Just a second. Minus 1. Now, you must have figured out the value of I. Yes, it is the square root of minus 1. And that is why it is called imaginary, because the square root of a negative number does not exist. Either you say it's rational or irrational, but the answer is that it is neither. It does not exist. And that is why the imaginary number has come, and that is the under root of minus 1. So I'm going to tell you something about I, some powers of the I. So let's say we have I raised to power 0, and anything raised to power 0 is 1. Now we have I raised to power 1. Oopsies, I think I should make it, yeah. I raised to power 1, and anything raised to power 1 is the number itself. Now I'm going to tell you about iota raised to the power 2, and by definition, let me just go back to the definition. It is minus 1. It is minus 1. And same way, now I cube. What is I cube? I cube is I square is I squared times I, which is equal to minus 1 times I, which is equal to, just a second, which is equal to minus I. Now this is the I chart. I call it the I chart. Well, I don't know what other people call it, but I call it the I chart because this is the only important thing. If you want to know about anything about I, you should know this. This is you can say the basics of I powers. This is the I power chart, and if you want to know anything about I power, you should know this. This is the basics of I power. Why is it called the basics of I power? Because, okay, so let's continue finding powers of I. Let me take I, just a second, I to the 4th power, and which is gonna be I to the 3rd power times I, which is gonna be this example goes a long way, so let me just take the short one. Okay, so I raised to the power 4 can be I squared whole square, which will be I squared, which I raised to power 2, which is I squared, which is minus 1 squared whole squared, which will be 1 squared, which will be 1. Same way, if I were to find I to the 5th, this is gonna be I to the 4th times I, which is gonna be 1 times I, which is gonna be I. If I were to take I to the 6th, and let me just put the arrow. Okay, wait. Change of plans. Extending the arrow till here. If I were to take I to the 6th, it would be I to the 5th, I to the 5th times, just a second, times I, which is I times I. Just the dot was coming. Yes. Which is equivalent to I squared, which is, by definition, minus 1. And I think I should take out I to the 7th. Yes. So I don't have enough space. Let me just split it over here. So wait, I'll just change the positioning of this thing. So you are till here. No way. You are just till here. That space is for I to the 7th. So continuing arrow. I to the 7th is equal to I to the 6th times I, which is equal to I to the 6th is minus 1. So wait a second. Minus 1 times I, which is minus I. Now let me just circle some answers which are coming common. Just a second. This is supposed to be minus I. Yeah. I'm going to circle the common. This is equal to this solution. I to the 1 with a different color is equal to this. I to the 1 is equal to I to the 5th. I to the 0th is equal to I to the 4th. I to the 1 is equal to I to 5. I to the 2nd, or I squared, is equal to I to the 6th. Wait, I don't have enough colors. What should I do? I to the 2nd is equal to I to the 6th. Oh god. Just a second. Is equal to I to the 6th. And now I have to use yellow. I'm having no other colors. I to the 3rd is equal to I to the 7th. So this is the pair and carries on. I to the 8th will be equal to I to the 0th and I to the 4th. Same way, I to the 9th will be equal to I to the 1st, I to the 5th, and that cycle carries on. Now, supposing that you were given to find the value of I to the 96th or I to the 1 million, whatever. How do you find that? I'm going to tell you an easy way for that. Okay, so let's say that we have to find the value for I to the 96th. Whatever the power is given, in this case 96, we take that power and we divide it by 4. So let's see, and when we what do we get as the remainder when we divide this as 4 with 4. So when we divide this with 4, we get 2, that's 8, that's 1, and 6, that's 4, and that's 1/6. So the remainder is 0. When the remainder is 0, all we have to do is we have to know the value for. We have to just make this I. Write the remainder and make it the part of I. So I to the 0 is, what is it? Let's see it. It is 1. So I to the 0 is equal to 1. Same way, if we were given to find of let's say what? Find the thing of, not this. Find any number 27. We would take 27 divided by 4. Let's divide it. We get 6. Actually, the quotient doesn't even matter, but we have to get the right quotient. 6, 24, the remainder is 3. So now we got a remainder of 3. So we make this 3 the power of I, and what is I to the third? It is minus I. It is minus I. So the answer is minus I.